Welcome back to Huawei Routing and Switching Elite Training for HCIE. Today topic we are going to discuss on WAN Layer 2 technologies. Let's start our part 3.
Next, we are going to look into the frame relay. Okay, so we are going to look into the concept of frame relay and what is LMI, inverse ARP, and sub-interfaces. So first, let's look into the frame relay concept. Now, this is a very important topic, especially in your HCIE exam, because in your exam, the frame relay will be the main connectivity for your equipment. All right, so let's look into the overall on the frame relay. First, let's look into the interface type. So here we have the DTE, which is on the customer here, as well as the provider. All right, the provider will be using DCE, which stands for data communication equipment. All right, and the customer using data terminal equipment. Then you also notice that this is my frame relay switch. All right, on the frame relay switch, the terminology here, we call this as a network interface. In fact, we also have this terminology we call as a UNI. This is called the user network interface. Okay, and NNI connect two FR switches together. So here we also have a NNI. Now next, we look into what we call as a VC or virtual circuit. Now virtual circuit is this. All right, so you can see that the dot here, this is the virtual circuit. So this is a logical circuit between two network devices on the same network. Now in the virtual circuit, we have a PVC and the SVC. Most of the time, we are using permanent virtual circuit and not a switch virtual circuit. Permanent virtual circuit will be permanently there, where we configure manually, whereas the switch virtual circuit is on demand. So when the frame relay is up, then the circuit will be there. When the frame relay is down, the switch virtual circuit will be deleted. All right, so most of the time we are using a PVC rather than SVC. Now next, we have a concept called DLCI. Now think of a DLCI as your data link address. Okay, but this data link address is used for the frame relay. So in this example, you can see that my DCE give this DTE as a DLCI of 100. You do not need to match the DLCI for both sides for them to communicate. All right, because the DLCI is locally significant. So this number is 100. In fact, you can also configure by the provider as DLCI 100 over here. So the number doesn't need to be matched, or if it's matched, also doesn't really matter, all right, because this is locally significant. So DLCI is to identify different virtual circuit, which means that in one interface, let's say this interface is S001, I can have DLCI 100, DLCI 101, DLCI 102 representing the destination that the virtual circuit is being connected to. So this one can be connected to branch A, this can connect to branch B, or this connect to branch C. So it's very critical for you to understand or to identify which DLCI are landed into which type of destination. Right. Now frame relay use what we call the LMI. So what is exactly is the LMI? LMI stands for Local Management Interface. All right. So the purpose of the LMI is to monitor the status of the PVC. Now, if you just look into this scenario again, if let's say I have a virtual circuit between router 1 and router 2, it looks like it's a point-to-point connectivity, but in actual fact, it's not exactly as in one single line. All right, so in actual fact, R1 connecting to your frame relay interface here, and R2 is connecting to this interface. Now assuming that if the connectivity on the R2 here fell, the status of the interface over here, let's say I have a 0001, the status will still say that it's up because this is not directly connected, as compared to if I'm going to connect using a point-to-point serial link on both sides. If this is down, the status here over here will be down as well. Now for us to solve this issue, we have to use a concept called LMI. Now in this LMI, the DTE, or in this case the customer, is going to send, the customer router is going to send a LMI status inquiry to the DCE, in this case our frame relay switch in the provider side. Now if the virtual circuit on the other side is up, well, then the frame relay switch is going to send back the LMI status saying that, hey, alright, the circuit is okay, is up. Now assuming that this is down, well, I'm going to say that this one is down, the circuit is down, then automatically the virtual circuit will go down. Alright, so that is the main thing on the LMI. Now in Huawei, we have three mode of the LMI, or three type of LMI. So we have a Q933, that is the NXA, we have NC, and we also have non-standard. The default for the Huawei is using an NC. Okay, so on both sides, we have to match the standard. But assuming that you are connecting to a non-standard other than Huawei, then you should use the non-standard. So the LMI protocol is used to manage PVC, alright, including the deleting and the integrity of the PVC and the status of the PVC, which is very important. Later when we go into the lab, I'll show you the command to check the LMI status. Now once the frame relay LMI status is active, alright, so they'll move into the layer 3. So regardless of what type of layer 3 that you are using, they need to have a mapping. So they need to map a layer 3 protocol into the DLCI. Now one way for us to solve this issue will be using inverse ARP. Now firstly, R1 is going to send an inverse ARP request to R2. Now R2, upon receive it, is going to respond to the R1 mentioning that they are using this particular IP with this particular DLCI, and R1 upon receive it will be registered in the frame relay mapping 12.1.1.2, okay, to the DLCI of 100. Okay, on R2 is going to do a mapping of 12.1.1.1 with a mapping of DLCI of 100. So this mapping is in R2 and this mapping is in R1. So once a mapping is done, R1 know that if I want to go to 12.1.1.2, I'm going to use a DLCI of 100. Now this is true if let's say you only have using one DLCI. Now if let's say you are using multiple DLCI, so assuming that now I have my FR connect to my router, and here I have a multiple DLCI. So when you have a multiple DLCI, there will be a possibility that inverse up map to the wrong DLCI to the wrong destination. So under such a circumstances, we should undo the inverse ARP. Alright, so we should use a static mapping instead of the dynamic mapping. Now frame relay work on the concept of a virtual circuit. Alright, which means that if I have one circuit, or in this case one interface, okay, one interface, I can create multiple virtual circuit into here. That's depend on what are the DLCI that you have. So assuming that I have 100, 101, and 102. So I may have three virtual circuit, but all of these exist in one single physical interface. Alright, so what is it to do with our concept called sub-interface over here? Now firstly, if assuming that I have a router, okay, all these are connected to the FR, and I have a router that connected to here, R1, then I have a R2 over here, and I have R4. Now let's say now we are running on RIP. If I'm going to use a interface, okay, of a S10/1 on R1, I'm going to configure RIP from R1 to R4. There's no problem. But what happens if let's say I have this physical interface, I want to exchange RIP route to R2. So R1 network that sent to R4, R4 is going to send back to R2 using the same interface. Now that is already have a violation of the split horizon. Okay, so for us to solve this split horizon problem, we are going to create what we call the sub-interface or sub-interfaces. So what it means over here is for each of these interface, we are going to create the different subnet. Alright, so S0.1 will be one subnet, S0.2 will be another subnet, and so on and so forth. So each of these we can configure point to point or point to multi-point. This is for us to solve the problem of the speed horizon. So later on the lab, we are going to look into how we can do a mapping of the DLCI to the sub interface, and we also will look into how we can configure that on the hub and spoke. Alright, which is very important in your HCIE exam. So it's time for us to look into the configuration. So I have multiple lab to show you. First, I'm going to show you the PPP configuration. Then I'm going to show you the multi-link PPP, PPPoE lab, and finally the frame relay. Now let's look into the first lab here. So this is on the company A environment. So perform the following configuration. Set the encapsulation type interface on R1 and R2 to PPP. And this is by default is already being configured because in Huawei the default encapsulation is PPP. Next, set the IP address of S00 of R2, which is here, to this IP 12.1.1.2, and configure R2 to allocate 12.1.1.1 to R1. So which means that in R1 I will using a dynamic IP. Alright, so assuming that R2 is the one who assign you IP, and the IP that you are going to assign for R1 will be 12.1.1.1. Okay, remember that in PPP we can do both a static or the dynamic negotiation. And the third requirement is to configure R1 as authenticating party. So in this case, they require a PPP authentication. R2 as an authenticated party, so we have authenticated party that's using chat. Okay, the username will be Huawei and the password is hello. Configure R1 to send a challenge packet, alright, with the user of Huawei to R2. Okay, so this is a single way authentication using chat. Alright, so let's just jump into the lab and see how this is being done. Alright, so this is our lab. I have R1, which is authenticating party, and I have R2, which is the authenticated party. Okay, so let's jump into R1 now, and let's see here. We have nothing here, no configuration or whatsoever. And first, we are going to configure our user. Alright, the user will be the user used by authenticated party to do the authentication on PPP. And as per the question, we are going to create a user called Huawei with a password cipher called hello. Okay, oops, sorry, I'm going to use hello, H-E-L-L-O. Alright, then I'm going to use a user to specify that this user service type is PPP. Alright, as you can see that we do have many type of services, but we only need PPP. Okay, so display this. I have the user Huawei PPP and the user password is being ciphertext. Next, I'm going to configure the interface of the serial 100. As you can see that the default link protocol encapsulation is PPP, so we do not need to configure anything. The question requires us to configure the authentication using chat. So here we are going to configure the authentication mode. As you can see that we have two modes here, PEP or chat. So we are going to use a chat. That's it. So that's all you require to configure on the R1 for the authenticating party. So on R2, which is authenticated party, I'm going to configure the interface as 100. This is the authenticated party. I'm going to configure the PPP chat user. The user is called Huawei. Okay, and PPP chat password cipher hello. And on top of that, this is the IP address. This router with the IP address is fixed. So I have an IP address of 12.1.1.2. Alright, 24. Now the question also mentioned that R1 are supposed to get the dynamic IP from R2. Now let me jump back to R1. I'll show you here. Display this. You can see that they do not have any IP address yet. Now where R2, I have the IP address, okay, that is stated over here. Now at the same time, I also need to assign the IP address to R1, and for me to do that, I use a command called remote address 12.1.1.1. Okay, so this is the address that I'm going to assign to R1. Right, and for me to do that on R1, I need to request for it. So the command is IP address PPP negotiate. Right, that's it. Okay, so you can see that the interface is up, display IP interface brief, and I have the up interface. If I go to R2, the interface is also up, authentication is fine. Let me do a display interface serial 1/0/0. As you can see from here, the protocol is PPP, IPCP is open, LCP is open. Alright, so if I do a ping to 12.1.1.1, as you can see that it's pingable. Alright, and I also can see that if I go to the R1, because R1, the IP address is being assigned. Alright, as you can see, it's 12.1.1/32, and if I want to show you the connected interface, okay, so here I have the directed interface 12.1.1.1, okay, and that is on the serial 00. So that is how simple you can configure the PPP using dynamic IP as well as the chat authentication.
Thanks for watching. Please do not forget to subscribe to our channel.